this week, we'll start talking about classes and objects in the lectures. However, given that you have already completed week number 6 Java tutorial videos, you already got some hands-on experience of object-oriented programming in Java. And we'll simply just try to reinforce many of the concepts which was already covered in the tutorial videos. And also, given that you have completed lab number 5, it would be a better timing for you to appreciate the concept right now. All right, let's now first talk about the objectives and also the assumptions I make about the lecture for this week and also next week. Let's first see the assumptions. Okay, so it is assumed that you have already completed week number 6, the OO introduction Java tutorial video. You can see all the links over here just for your convenience. And also for week number 7, it was just released about a couple of days before this current lecture. So you should really try to complete it as soon as possible. That one there also go further into talking about aliasing and also reference type attributes. Next week, before your weekly lecture number 8 is released next week, we will also give you the week number 8 Java tutorial videos, most likely next Friday as usual. But before that, I would suggest you really want to complete all the tutorial videos in time and also to complete the lecture as well. So things will actually connect to each other more smoothly. And also, there are 2 written notes. You have to make sure you also study them. Okay, let me just mention them very quickly to you. The first notes is really about how you can invert classes and methods from JUnit tests. So that's really the formats of the lab number 5 and 6, and also your programming test number 3. So this is something you are supposed to read, so I'm going to let you read it. If you got any trouble, let me know. And also for the new Java tutorial video for week number 7, I also refer to you this particular written notes. The example is about point collector and also point collector tester. But the main learning outcome is really to understand how to declare and also how to manipulate reference type and also multi-value attributes, how you can manipulate them using loops and also if conditionals. So that'll be very important for you to actually get used to it. For this week, you have to read the notes and also to study the tutorial videos, week number 7. And then next week, I'm going to explain a little bit more in the Eclipse and also in the lecture about this particular programming pattern. But you should really study the notes first so you can really get the best learning outcome for the subjects. All right, so that's about the assumption I want to make about the lecture. I'll try to make the lectures themselves as brief as possible since you already learned quite many valuable concepts in the tutorials already. So we don't need to repeat so much. I'll just highlight those points that either are very important, I just want to repeat quickly, or those points that were not actually mentioned in the tutorial videos. So that'll be my main strategy for the lectures. All right, so let's talk about learning outcomes very quickly. So we want to understand, number 1, about object orientation, including we want to talk about classes as templates. And whenever you declare classes as templates, you have to define attributes, constructors, and also methods, including accessor and also mutator. You have already seen how to program them individually. And also how to use the this keyword, which I will also review again quickly this week. And we also talk about objects as instances. So how to use the new keyword to create a new object to allocate some space in the memory. And also how you use the dot notation to really get access to the methods, either accessor or mutators, how you can invoke methods. And whenever you invoke the methods, you have to replace the context objects into this in the definition, right? That's something you have seen me tracing in the tutorial video. I'll do that in some small simple example once more just to emphasize. And also we're going to talk about reference aliasing, which is what was covered in your week number 7 Java tutorial videos, but I will also cover them in using different examples in the lecture this week. All right, and then we're going to talk about reference type attributes, single value versus multi-value. When we say multi-value for this course, we're going to first using a primitive array, and later, once we introduce library classes like an array list, we will use array list as well. But that's something for later, not for this week. And also, we'll talk about next week non-static versus static variables. So we'll explain the static keyword in more details next week. And then finally, we'll just show you how you can define helper methods to really maximize the reuse of your code and also minimize duplicates in your code. All right, so let's now first define the context. Where are we and where will we go? Okay. So far we have developed our Java code mainly in the main method when you're developing your console application, or maybe in the utility method, and to really exercise, how to use the procedural basics in Java, how you can use if conditional, and also how you can use loops as the body of the utility method. That's what we have done so far. However, so these methods, like a main method or utility method, have been created, have been somehow a restriction for you to really focus on your learning about the procedural basics in Java. But in general, it should be much more flexible. So we should really get to it. So in Java, in general, we may define more than one classes rather than just a single utility class in the model package, right? So in the model package, in general, you can have as many classes as you like. And even more general, you can have more than one model packages. You can have model package 1, model package 2, model package 3, and even with different names, right? That's the more general case, which we'll get into not just for this course, but later on, once you get to the advanced courses for example, software design, you have to create different packages and with different classes to organize your logic. Each class may contain more than one methods, right? You got constructors, you got accessor, you got mutators. Those are the classes you need. And given a JUnit test, you should really know how to invert all the classes and methods accordingly. And we talk about OOP, object-oriented programming in Java. So we want to use classes to define templates, right? So I will talk about some workflow conceptually in the next slides. So the most important thing for you to distinguish between classes and objects is classes are simply just templates at the compilation time. You just have some definition for attributes, methods, and constructor. And objects are things which you can create at the runtime. For each particular class, you can create as many instances as you like, right? So that's why we say instantiates. So instantiate is really the keyword over here. And then at runtime, we may simply create objects, of different types or of the same type, and we may call methods on the objects, right? And then such that we will simulate how the real life entities are actually working with each other. That's really why this paradigm for programming is called object-oriented programming. So you create different types of objects at runtime, and you let them work together using method calls. So that's why. All right. So I would like to talk about the way I understand about the process of OOP. I call it observe, model, and execute process, right? There are 3 stages. So this will be the diagram you will see on the slides. I will also make a larger one just for your reference. You can download it from the lecture site later. This is some tutorial video which will explore in details about object orientation. So this is something, this is one tutorial video I recorded back in winter 18 for also EECS1022. If you want to explore further about the object orientation, you can feel free to study this video. But for today, for the lecture, I will still cover just a little bit so you can just get enough information. But if you want to explore further, you can study this video. It's up to you. Okay, so let's talk about observe, model, and also execute, right? Observe simply means we want to observe how the real world entities behave. So entities are a very general term. Anything you can see through your eyes in the real world. So they are simply called entities. So for example, you might have an entity called keyboard. You might have an entity called monitor. You may have a entity called microphone, classroom, desk, trees, forest, sky. So these are all the entities, but entities might have different types as well. And once you observe, you want to choose a set of entities you want to really you want to actually implement for your application. So you want to model each type of entity you want to include in your application. And for each entity, you want to include their attributes and also their behavior. So these are the 2 words you want to get used to. That's something you have done already in your tutorial videos and also in your lab, but I haven't really seen the formal term. So attributes are simply just a data that the entities store, and the behavior are simply like an operation you can perform on the objects. You can think about all the methods are to define the behavior of a particular type of entity. And then finally, once we model everything into a single class, and then we can instantiate as many instances as we like for that particular class at runtime. So we will execute, right? Execute simply means we're going to run the program at the runtime. And then by creating instances of the classes which interact in a way analogous to that of real-world entities. So the last phrase over here, analogous to that of real-world entities. This is why it is called object orientation. Okay, so that's why. So this slide here really summarizes about the high-level philosophy of object orientation, which is really important. So you're going to use OOP, not just for this course, but also for 2030, 2011, and even your software design course and later. So this slide is always the high-level philosophy you want to obey when you do OOP. Okay, and let me speak very briefly about this process here: observe, model, and execute. Just to summarize quickly. So we talk about object-oriented programming, or OOP. In real life, lots of entities exist and interact with each other. So here, it's really important for you to know. Number one, there are lots of entity types, not just a single type of entity. There might be entity for cars, might be entities for person, and etc. And most importantly, they interact with each other. So they don't simply just exist in isolation. So example, we make up people here. You can see gain, lose weight, marry, divorce, and also get older. So this is the kind of like a member class that we spoke about in the Java tutorial video. And also we got cars, and which will move from one point to another, and also got two-dimensional points, on the 2D plane as well. And also clients, let's say we talk about bank application. So you can think about anything you can see either tangibly or untangibly. They can always be modeled using classes. You can always create templates by anything that's observable. All right, so we talk about entities. Let's see some definition for entities. So they possess attributes. So attributes are like the characteristic you can describe about a particular kind of entity. For example, if you talk about the entity for person, like a people, what kind of attributes can you use to describe, to characterize people? You can say maybe the weights and heights, name, nationality, and etc. Right? So what attributes you decide to really use to characterize a particular kind of entity is completely up to you. Okay. It's more like a modeling process. And also possess attributes and also exhibit behavior. So for example, people, each person might gain weights. It's more like an action, more like a behavior. They may also lose weights. They may marry to somebody, or they may divorce, or they may get older, right? So many other behavior as well. You can think about whenever there's any behavior happening for a particular entity, so that means their attribute values might just be subject to changes. That's kind of the principle. Okay, and also they might interact with each other. So for example, two person might marry to each other, and two person might actually attend the classes together, or maybe one person becomes the academic advisor of another person, right? So there might be different kinds of interaction you might have. Let's now go back to the process over here, right? Remember we talked about the process. From what I have described up to now, is really so-called the observe process. You can think about over here. So the one I'm going to highlight over here. So this is so-called the observe process. Observe. So this part here is called the observe. And whenever you observe, you're going to observe the entities, different kinds of entity. You can think about the first kind of entity. I simply use a cloud to say they belong to the same kind. So the entity could be just person. For example, Jim is one example for entity person, and also Jonathan is just another one. And there might be another kind of entity which is completely different from Jim and Jonathan. So it would be the entities for maybe maybe the points on a two-dimensional plane. So here could be P1, where X and Y coordinates are simply 2 and 3, and also P2, which is another instance of the points. So you can see these are entities of a particular kind, and these are entities of just another kind, right? So when you observe, you simply observe to see what entities there are out there in the real world. So that'll be the first process. And then let's see what the next process will be. The next step in the process will be. If I go back here, you can see the goal is really to solve the problems programmatically by, let's see. Number one, we want to classify the entities of interest. So here you can see there are, in the real world, there are many kinds of entities. It's simply unbounded number of entities. However, you don't necessarily have to model or turn every one of them into Java code. You don't have to. You only have to be selective about what your application might need, right? So that's why you got to be selective. Okay, so classify entities of interest. So that's really important. And then entities in the same class share common attributes and behavior, right? Remember, every kind of entity is going to be characterized by their common attributes and behavior, right? So the attributes and behavior for a person will be different from the attributes and behavior for two-dimensional points. They're simply different, okay? And then manipulating data that represent these entities, right? So you're gonna manipulate by defining methods. Okay, so that'll be the second step over here. Let's now highlight it. So it will be the middle step. So this is what I call the model step. Model. Okay, so let me write it down. So this part here is simply for model. And when you actually model, you're going to, let's say I choose to really model this entity over here, and also this entity over here, the purple and the orange, right? And now for the purple entity, I'm going to I'll turn that into this particular class called person, right? You can see. So now we got. Remember, we talk about attributes and also methods. So here I'm only listing the attributes. So every person actually got a name, weights, and heights, and every points template over here I'm defining. They have both x and y coordinates, right? You can see they actually simply got different characteristics in order to model them. So that'll be the second step. And in general, you can model as many classes as you like. It only depends on how many, what classes you really need to solve the problem for your application. You can have as many as you like. For this course, you don't really have to be the person who actually decide what classes you will need. Typically, for example, let's say for your lab and also for your programming test, you're simply given a JUnit test. Suggesting the classes and method you will need to program. So the design decision has been already made for you. And that will be pretty much the case for later course like a 2030 and 2011. However, once you get to the software design course, you will be you will need to be more proactive about what classes you will need. That's for later. Okay, but one step at a time. Okay, let's go back here. Okay, and then so here, the last point over here, manipulating data that represent these entities, and also each entity is represented by specific values. So this part is really about when you execute the objects at the runtime. So every instance of this instantiated from the same template, they might simply got different values specific to the instances. Let's see how. So that will correspond to the third step of the process. So the third step would be this part over here. This is what I call the execute process. So this will be execute stage. And you can see for the execute, it's going to be talking about runtime. Whereas for the model process, is talking about compilation time, right? So just notice the difference over here. And then you can see now for this particular person type, I can instantiate as many objects as I like for that particular type. For example, you can see Jim and Jonathan. So these are the two objects of this particular entity type. I got Jim and also got Jonathan. And now notice one thing. You can see now Jim and also Jonathan at the runtime, they somehow are analogous to the Jim and Jonathan I actually observed initially, right? You can see it is because this particular modeling process that will make it possible for me to simulate Jim and Jonathan that actually who actually exist in the real life over here. So that's really about object orientation. And similarly, you can see here I got these two objects of type points. And remember how we show you about how to visualize objects. I'll say that again later. But you can see the title of the box is simply just point, and we got x and y, the attributes over here. So all the points objects got x and y. However, individually, they might simply got different values. For example, 2 versus -1. They are actually different. So that's what we call instance-specific values for the attributes. And then you can see the P1 and P2 over here. They simply correspond to the P1 and P2 that we observed in the observed stage over here, right? You can see. So it's really important for you to see this three stages process over here. Observe, model, and execute, right? So that's something you want to always keep in mind when you're doing your object-oriented programming.